Okay, so in this one, we're going to take a look at something completely different than what we've done so far. And what I'm talking about is the FFT node of Nuke, which stands for Fast Fourier Transform. And what this FFT is doing is giving us a possibility to see our image in a completely different way. So just like in audio, the image is composed of various frequencies. So there's the low, mid, and high frequency. So by doing that, we're able to do various process, much like we're doing with audio. So imagine you have a song that has a problematic frequency, maybe in the high frequency that is doing a very high annoying pitch. So very often what the in audio process what they do is they're just able to isolate this very precise frequency and tune it down so that the bad frequency is not in the song anymore while keeping all the other thing around it. So with the FFT node, we're able to do that kind of process but with an image. So for example, if we take a look at this footage here, we see that there is a very bad pattern everywhere in the image. So that's the kind of problem that could happen if maybe there was a bad cable on set, or maybe the sensor was doing went very wrong and had a problem, or there was some interference in the transfer of this video. So as you can see, there's some very bad line everywhere in this footage. So normally, that's the kind of thing that would be very hard to fix because there is a lot of detail in the video, but still we see that the artifact is very strong. So by just using something like a noise reduction, this just won't work, because to get rid of that amount of problematic pattern here, that will also destroy all the detail that we have in the image. So we'll use the FFT to just isolate the frequency that is doing this bad pattern in the image while keeping all this nice detail that we have here. So now how do you get the FFT node inside of Nuke, since it is a hidden node? So there's two ways you can get to this node. The first one by hitting the X key. And now Nuke will show you this command dialog box where you can just type the FFT command, and this will call for you the FFT node. So that's the first way you can get to the FFT node. The other one is to update the all plugin of Nuke. So if you go in this toolbar here and click on this icon and go in all plugin, if you click on update, Nuke will then load all the different plugin and gizmo that are not loaded by default when you open Nuke. So if you go here on all plugin and click on the update, then you'll see the FFT node here when you hit tab. So that's the other way you can get to the FFT. So let's take a look at what happened when we connect this FFT node to our plate. So if we take a look at what we got here, is basically some random noise. So let's lower the viewer exposure to have a bit more detail. So we'll just lower this exposition like that. So basically what we're seeing now is all the different frequency that I was talking about. So you can see the left part here representing the very low frequency, which are the most important pixel or frequency of your image. And as we move to the right here, that's where we'll have your high frequency. So those kind of pixel or frequency are contributing a bit less to the image. So if we take a look at what we've got, we see that we have, if we take a look at the actually value here, we have some very large floating value for each pixel. And that's the amplitude of each frequency. So let's make a paint node actually and reset the viewer exposure. So you could have, let's say, a frequency with an amplitude like that. And then if we just change the color, maybe to something like this, then you could have some high frequency going in your image like that. Then maybe you have another kind of frequency contributing to your image. And let's do a last one, something like that. So all those pixels that we see here is driving one frequency that when they're added one to each other, then what they end up is making this final image. But what happens sometimes, like the case here where we have some frequency that went completely crazy on the roof and made some really weird pattern. What you will get is maybe something like you'll have a frequency that is completely crazy. But how do you get rid of just this frequency when you are in RGB mode? It's just not possible, because you can't tell what is a problematic pixel and what is a good detail pixel, or maybe what is a grain pixel. All those are mixed together and you cannot get rid of just one. But if we get here, what the FFT mode will allow us is pick one frequency and just disable it, something like that. And what you end up is all the good frequency that is making all the rich detail of your image that you really want to keep. So that's what the FFT will allow us to do. So going back in the FFT now, just delete this paint node that we don't need. Going back in the FFT and lowering down the exposure, something like that. Now, we see that we have our detail here, but we have some white spot here and on the bottom here. And you see that they're very popping out of the image as they're surrounded by darker frequency. So that's a good sign of what is going wrong with the image. And the idea here is to isolate those frequencies and delete them from the image, so that when we'll recombine all those FFT frequencies back to RGB, what will end up is the good one that are making all the important detail, but we'll get rid of all the one that are making our image a bit crazy. So let's first call the node that will allow us to get back to the RGB value. So it's pretty easy. You can it's the invert FFT, which will invert the FFT and get back to the RGB. So if now we connect this to our FFT node and take a look at this, we see that we get back to our original image without any difference at all. So now the goal is to go here, find the problematic frequencies, delete them, and then recombine this into RGB. So what we'll do, there's a way you can do that. You could do it with a paint node and delete those, paint out those frequency, or you can even do it, let's say, with a quick roto. So we'll just connect a roto inside the FFT, and what we want to do is paint in the RGB, and the shape that we want to draw, we want to actually kill the frequency, so we'll want to make them completely black. So going the shape here, we'll just draw a quick shape around this. So let's make a rectangle. So just delete this one and make a new one. So draw our rectangle here. Let's draw something like that. Just make sure the color to be black. And then we'll make a new one for the one that we have here. So just draw another box like that, just on top of what seems to be the problematic pixel. So now if we put this in black and go back in RGB now and raise the exposure again. Now let's see the kind of difference that we have before and after. So let's find this region where we had some good detail, and let's disable the roto on and off. So I don't know if you can see it on the screen recording, but let's say we take a look at this region here. Now if I enable the roto, you see how much artifact we're losing while keeping all the detail of the original footage. So the idea now, let's say we want to do it with the paint node, we could also do that to be a bit more precise. So we'll call it paint node, and we'll just call the reveal like that. And actually, to see what we're doing in context, we'll just make a new viewer so that we can see the FFT while seeing the result in RGB. So make a new comp viewer, drag it right here. So we'll take a look at this region while tweaking the FFT here. So we'll lower the exposition to see some detail, something like that. So now if I go in my paint and just make sure that I'm painting in all the frame. So I'll switch to all. Now go in back here, select my paint node, make sure I'm in reveal, and take a look at what will happen here while I'll be deleting those pixels here. So I'm just painting out some problematic pixel like that. And I'll do the same thing here. So you see how we're losing this. So the idea is to just be as precise as possible and delete what is making the strange pattern. Like that. So that's the before and after. So you see how using the FFT node you can fix some really problematic image. And I know it's not the kind of tool that you're going to use every day, but if you ever happen to have an image with very weird pattern in it, use the FFT node, and if you see some bright spot somewhere in the FFT, rest assured that if you have this bright spot and you delete it, you'll probably save your image, because most of the time when you have this kind of problem, you'll see something in the FFT. So just to show you how much important all those frequency here compared to what we have here, I'll just delete this paint here so we get back to our original image, and I'll just add a new roto and again select, so I'll make a paint node and select the reveal tool, and look what will happen when I'll delete all those frequency. So I'll just paint out a lot of detail like that, and I'll zoom in and let's say something like this frame here. So I've deleted a lot of things here, but you can't really see a big difference in your image. So I'll continue to reveal all those frequency here, and I'll continue to go on this way, and now you're starting to see how we're all starting to destroy the image, and that's because I've just painted on this line here, which contain a lot of important information. So I could continue to reveal like that, and what will be still keeping quite a lot of detail actually. But look what happened if I just zoom here in the middle left part, and I'll just reveal this pixel here. So look what happened. So that's exactly what I was telling you, that this is the most lower frequency, most important frequencies of your image. So you really don't want to mess in this part here. But what you can feel free to do, and that will work most of the time, is when you have some very strong frequency that went crazy and produce very high pixel. You can easily delete them, and this will make sure that you keep all the other detail of your image. So it's not the tool you're going to use every day, but the time you'll have those kind of image, it will definitely save the day. And one last thing I wanted to show you with the F15 node is that you can actually grab the artifact of one image and put it on a new one. So for example, if you need to integrate the CG on top of a plate that has some slight artifact, you can use the F15 to grab it and reproduce it on your CG. But for this example, let's say that we want to apply the artifact on this new footage that is perfectly clean, but that maybe we need to match to this one. So what we can do is to put both footage in the FFT space. So now you have one FFT for your left plate and one for the right plate. So now the idea is to go grab those problematic pixel right here and transfer them to this other image FFT, and then recombine all of that in RGB. So what we'll do is we'll make a new key mix, and we'll connect one input to one FFT, the other to the other FFT, and then we'll just make a new roto. So we'll make sure that our roto is matching perfectly the resolution of our clips, which are HD. So just make sure that you're on HD. And then we'll connect this to the mask input. So now we'll just take a look at our problematic FFT, and we'll just draw a quick shape around this like that. And then we'll do the same thing for this one. So we'll copy what seems to be the problematic frequencies, like that, and then we'll combine them in one FFT using the key mix. So now if we take that and put it back in RGB using the invert FFT, what will end up is our original image, but now with the artifact of the other image. So that was the original. Now you see that we're adding all those problematic lines inside our new footage. So that's a very useful trick when you need to actually add artifact from one plate to the other.